All right, thanks everyone for coming out tonight. We have a guest speaker tonight, Jean de Klerk. He'll be speaking about Go modules. Just some quick announcements. First of all, just a disclaimer, we live stream our events. There's a lot of new faces here, so we live stream to Twitch and we also post it on YouTube, so it's a good way to get access to the talks if you weren't able to attend in person. But it also means that you're being recorded right now. Camera's not pointed at you, but your voice will be recorded on the audio, so just a forewarning. Besides that, I don't really have a lot of announcements this month. I know tickets for GopherCon are still open, and there's a conference up in New York, Gotham Go, which tickets are available now. They weren't available last month, so from what I understand, like that's kind of a smaller conference, so you might want to get your tickets for that early rather than later. Besides that, I think that's about it.
As always, the slide deck's available on the Meetup page for those looking for employment, or if you want to add to the slide deck, contact Jason or I and we can add you in.
Yep. That's about it. So, without further ado, John.
Cool. Hello, my name's John. I am a engineer at Google. I work on our Go libraries. And today I'm here to talk about multi-module repositories. Just as a heads up or forewarning, this is sort of like a beta run of this talk. If you go to GopherCon, you might see a bigger version of this. Right, so let's get started. So modules are finally here, mostly. So right now we are in 1.11. I like to think of this as alpha. You know, modules are a thing and you can use them, but there's a lot of rough edges and there's some bugs and that sort of thing. Actually, a lot of them have been ironed out because we're at the end of 1.11 right now. 1.12 is going to be coming out pretty soon here, and it's going to be a lot stabler experience, and then 1.13 it's going to be on by default. But due to the fact that we're in this transitionary period, it means some interesting things for library maintainers. And a lot of this talk is about maintaining a library in a module world, because I work on libraries, so that's what I think about. What we're going to do is we're going to look at a simple repo through this entire talk. This is just a made-up thing that I made. So here I have a repository. It is github.com Klerk Boulder 9000. It is a super duper code builder. Yeah, feel free to pop by. And within it, there's a couple of things that you might expect. There's a compiler package, there's a linker package, there's an internal, the compiler has sub-packages, and so on and so on. If you were to look at this in terms of a Go module, it's pretty simple. If you have a go.mod at the top, the entire directory structure is all part of this one module. You actually don't even need the go.mod, right? Because of backwards compatibility reasons, the repository is considered a module anyways. But for the sake of this talk, we're just going to consider things that have a go.mod as being a module, and then everything below that is part of that module. So this talk isn't about module repositories, it's about multi-module repositories. So let's take a look at what multiple go.mods look like. And this is what it is, right? So I have 3 go.mods here. So at the top I have a go.mod as before. I have a compiler go.mod and I have a linker go.mod. And as you can tell from this picture, the way it works is your package, any package, static, dynamic, generator, internal, any package is part of the module of its closest ancestor module, right? So optimizer down here, compiler optimizer, the closest module is defined in compiler, and therefore if you were to get the compiler module, you would get optimizer. If you were to get Builder 9000, you do not get compiler. You also do not get optimizer. This becomes relevant soon. To drill into this more and just make it concrete, the top level module is github.com Klerk Boulder 9000, really simple module names, as Go usually does. And then the module names for the like children or lower level modules are as you would expect, right? It's github.com builder 9000 /compiler /linker and so on. So it's just the path. And there's, just from the name, there's not really any way to tell that these are like children, I guess. Or wait, sorry. You can't tell that they are children because their names include the same path prefix. Okay, and you can have as many as you want and at any level. So here I'm breaking out Lexer into its own Go module, and the only thing that takes is another go.mod. In terms of dependencies, each of these modules can depend on each other. So linker can depend on its like upper level. I'm trying not to say parent and child because it's not really like that, but it can depend on the module that includes its path prefix and vice versa. Linker can also depend on internal. That is completely fine. And so on and so on. Internal, by the way, is not special. Like internal can be its own module too. That is completely fine. Okay, so I work on libraries, and so we are going to explore what it means to take the dive of putting multiple modules in your repository. So, because it's actually pretty dangerous. So let's go back to the top. This is our initial state. We just have this one module. This is what most libraries look like today. Most repositories look like this too. And we want to add more modules. We want to maybe like expose compiler and linker. Maybe we want this kind of a state in the future. So how do we do this? And let's just imagine that right now the state of the world is we are at version 1.0.3, right? Just some random version. We're going to go for it. So here's a really naive way to do it, right? We cd into compiler. We want to make this its own module. We cd into compiler. We do a gomod init. This just creates an empty go.mod. And then we do a gomod tidy, which codifies dependencies. And then we commit it and we push it, right? No. We skipped a step, which is that we actually need to formalize it by giving it a version. So what does it mean to do a version for something other than the root, right? If it's the root, I can do like git tag v1.0.4 or 1.1.0 or something like that. But what about, how do I create a tag for something that's not at the root? And it's actually pretty simple. So compiler /v1.0.0. And this is just a way, this is like a well-known format that Go module knows about. And it codifies that compiler, the compiler module is at v1.0.0. And then, so the root doesn't need any path because it's the root. And then any module that's defined below the root of your repository needs this path. And it's relative to the root. We'll take a look at that a little bit closer here. So here's a couple of examples. Again, if you just have a version, that is saying that I expect there to be a go.mod at the root of the repository. If there's a path, then it's from the root. This is where I expect the go.mod. So pretty simple, but not, widely known. Okay, let's go back to this. Whoops. So we're going to take a look at this in more steps. There's actually more problems here, and it gets a little bit more subtle at this point. So what could go wrong? Well, so this is what happens when a user depends on your module, right? What happened here is a user is using compiler. They have two dependencies in their go.mod now. They have builder 9000 at 1.0.3, and they have builder 9000 compiler at 1.0.0. Both modules provide the same package. And as you might imagine, you cannot have two package definitions when you go to compile. So you get this lovely error, which is basically telling us that, hey, I tried to go compile your program, and this package, this compiler package, I found it in this module, this compiler 1.0.0 module, and I found it in this module too, 1.0.3. So you need to go figure that out before we can compile. So, so here it was before. I'm just going to be super clear about these, and I'm going to use pictures to kind of drill these points on. So here it was before. And this is another way of looking at it, right? I'm going to talk about this in terms of package import and module imports, because they're kind of different things. So here's some user package before, and before we split it out, they would depend on Builder 9000, and Builder 9000 is this whole kind of circled thing, and it includes both packages. Easy peasy, no problems. Now here's what we do afterwards. We split this thing out. I'm actually going to use the phrase carve it out. We carve it out of Builder 9000. And this is where the problem occurs. Is now, when a user goes to depend on it, now they have two dependencies in their Godot mod, right? They still have Builder 9000 because they're using something in that package. And then they have the compiler. And now the compiler is provided by two different modules. Okay, so this is no good. We also can't rewrite history, right? So once you have shipped Builder 9000 v1.0.3, you can't go back to 1.0.3 and like, oh, I actually need to cut this out, right? Or 1.0.2 or 1.0.1 or any of the 1.x's. You can't go back and cut them out for sort of like common sense reasons and then also technical reasons. Like there are these things called module proxies that cache your modules, and you can go make changes to GitHub all you want, but you cannot go to these module proxies one by one and go rewrite history. So we need some way where when we carve out a submodule, we need to force users not to run into this problem. And thankfully, there is kind of a solution. I don't know why I have this slide. Okay, right, so there is a solution. So here's what we had before. And we're going to fix this process so that when we push this 1.0.0, any user that depends on it is guaranteed not to break, which a library maintainer needs to care about. And here's the change. And I'm just going to talk about it very briefly here, and then we're going to go into an elaborate thing about why this works. So what you're going to do is when you go into compiler and you're creating your 1.0.0, you are going to add a dependency to Builder 9000 to the parent at a version that doesn't exist, a 1.1.0. And then you're going to do a single commit, and you're going to tag that commit, that same commit with two tags, a 1.1.0, which now this exists once you push this, and a what we had before, the compiler 1.0.0. It is crucial that all of this happens as a single commit. There's three things happening here that have to happen all at the same time for this to be atomic. The first thing is that as part of our commit, we are going to add an addition to our go.mod in compiler. The second thing is that, well, I say addition, actually, it's just the initial go.mod. The second thing is that this 1.1.0 tag is going to go with it, and the second one is the compiler 1.0.0. Let's see why this works. And really, this is the secret magic, and it has to do with MVS, minimum version selection. If you haven't read Russ Cox's 250-page report on why dependency management has to work this way, you know, you're just missing on great reading. It's very just so easy to get through. I'm just kidding. It's not that easy. But the TLDR of MVS is that it's going to choose the minimum. It's called minimum version selection, but I'm going to say it chooses the minimum viable version, right? Without elaborating on that too much, let's take a look at that visually. I'm a visual person. I hope you guys are too. We have two modules here that users are depending on. If a user pulls in any of these Builder 9000 compiler modules, like 1.0.0, 1.0.10, or sorry, 1.0.1, and one of these pre-carve out, they get two compilers, right? All of these previous ones before we carved out have two versions of the compiler package. And so none of these are compatible with these compiler modules. We really want users to use 1.1.0, 1.2.0, you know, any of these made up like post 1.1.0 modules. We can tell users to do that, you know, like verbally and through newsletters and stuff like that, but it's a really bad experience. And if you're a major company shipping big libraries, that is absolutely not acceptable. You have to encode it in so that anyone using the tool will just automatically get this change. And so we're going to lean on MVS, right? So what we don't want to happen is a user to pull in the right side and then the left side at anything below 110. When we add that dependency right here, we are forcing the GoMod algorithm, the MVS, minimum version selection algorithm, to not consider anything below here. Because adding dependency here tells Go modules, hey, look, the earliest version that I'm compatible with Boulder 9000 is 110, so don't even try to pull anything lower, right? That's the magic of MVS. And it's happy to pull anything above that, but it's not going to pull anything below. And so now, when a user tries to pull stuff in, even if their go.mod says 100 of Builder 9000, even if they specifically said that, because we care so much about Semver and because MVS is okay with pulling anything above the version, that's your minimum version, it says, okay, well, the user wanted this, but it's not compatible. So I'm just going to pull up to the most recent compatible, the minimum compatible one, which is 110. And the problem is solved. So this is kind of a crazy thing that we ran into. When you go into modules as a library maintainer, you sort of have to be aware of this, because unless you can think of every single module that you need at the very inception of your library, you're going to run into this problem one day. And it is incredibly easy to shoot your users in the foot. And not in like small, subtle ways. It's like, no, your program just doesn't compile. Okay, so that's the main thing that I wanted to talk about. The next thing is kind of a subtle thing too, but it's more of an aside to this. I'm just going to pause here for a second. We'll do more questions at the end, but just initially, any questions anyone wants to talk about? Yes?
Basically on what you just said, because you said MVS, if you say that you want V100 of the compiler and you want to get V100 of Builder 9000, it'll grab V110. Is it going to give you any kind of like warning, like the version you chose is wrong, I'm going to give you this one, or is it just going to say like, you actually just wanted this one here?
So that's an interesting thing about MVS, or an interesting consequence, is that when you put import or require statements into your go.mod file, you're not saying pull in this version. You're actually saying this is the minimum version within this major that I'm okay with. So MVS will never bump you a major, but it'll bump patches and minors without telling you for days. And I think you can take a look at your go.sum if you want to see which actual versions you're getting.
I've got a question.
Yeah.
So by adding that dependency, you're not actually going to be using it. Say you're not going to use any of the code in that dependency.
Right. So you would add an underscore dependency in a package. So let me expand on this. If you just add the dependency, let's bump that all the way to here. If you just add this dependency, but none of your packages import it, none of your code actually uses this dependency, and then you do a go-to-mod.tidy, blown away, right? So what you need to do in that case, if you don't actually need that code, you need to choose a package that you don't care about and put an underscore dependency. Underscore is significant because you don't have to, if you add a dependency but you don't use it, you'll get unused dependency compile time errors. If you add an underscore dependency, its significance there is that the compiler doesn't complain that it's not used. It's just okay with you just having it there but not using it. And then that lets Go modules think of it as something that you actually depend on, and so it won't blow it away. It's like formalizing it. Yeah.
That underscore dependency goes into your import clause?
Into an import clause, yes. Yep.
Well, but that means you're actually going to be including the code into your compile thing, right?
So you
That's
can.
not ideal.
Yeah, totally. You can get around this too. There's just so many tricks. You can get around this too by having, what we do at Google is we will build a file that has a build tag, and it's a made up build tag. So we'll do like @build tools or something like that, which means that Go modules thinks you need it, but when you go to compile, it doesn't become part of your binary. This is also useful as a library owner because if you have any CI tooling that you want to encode in your Go mod file, you would create the same kind of file, and that's the file that we make actually. And then it's part of your go.mod, but then it's not part of your binary. and it's not part of, more important, it's not part of your user's binaries, and all the transitive dependencies is nice. As an aside, the downside to that is that it makes it really hard to understand your transitive dependencies. Any more questions about this? Yeah.
I have two, actually, maybe think of one.
Yep.
This might be out of scope, so just tell me, but do you know if there's any thought to adding better support for that situation?
Yes.
Making a big file seems kind of circuitous for a tool.
Yes. Let me see if I have that slide. I thought I had added that, actually. I thought I had added that, and it's a little strange that I don't see it now, but the TLDR is that there is a proposal by Brian Mills, who's one of the co-authors of all this module stuff, which basically lets you take a directory and tell your, oh, actually I do have a slide for it, but it's further on. It lets you take a directory and create a fake local module for it, like fake out your module cache to think that this is a real thing. And wait, how does that solve this one? Maybe that's not about this one. No, sorry, completely different thing. We're going to get to what I just said in a second. To answer your question about this, there is a tool coming. It is called Go Release. It will help with the release process, and it will put a bunch of wrappings around stuff like this. Yep.
Just a meta point for the recording, if you don't mind repeating the questions. Some folks in Slack were asking if you repeat the questions.
Yep.
Some other people were asking about MVS, what MVS is. So some people here might already know that, but maybe you can clarify that.
Yep. So the question is, what is MVS? For people remote, sorry, I will now start saying questions. What is MVS? MVS, minimum version selection, is the algorithm underpinning Go modules. It is, in the context of this talk, we'll just describe it as it chooses the minimum version out of all of the versions specified in any go.mod file for a particular dependency. So it matters for us right here. Wait, sorry, here. Over here, there's two specifications of Builder 9000. The user's go.mod says, I want Builder 9000 at 100. The Builder 9000 compiler go.mod is saying, I want Builder 9000 at 110. Right? So we have two versions for Builder 9000, 100 and 110. Minimum version selection is just going to choose the minimum of all of the viable versions, which would be, or the minimum viable version of all the versions would be 110. Right? It cannot choose 100 because we already know for a fact that Builder 9000 compiler is not compatible with anything below 110. So that's why it chooses 110. Any other from the stream? And then I'll get to yours.
No,
Okay, yep.
What is the kind of original motivation? Like, why do you want to do this versus just using Builder 9000 at 110 and
Yep.
import the package you want?
The question is, why do any of this crazy shenanigans? Why put yourself in this situation? Great question. The answer is please do not do multi-module repositories unless you know for a fact that you need it. Some examples of why you need it. Why we need it at Google is one of our repositories has dozens of completely distinct clients, and another repository has hundreds of completely distinct clients, each with their own set of dependencies. So when a user goes to depend on, currently we just have a single module. We plan to do multi-module repositories. When a user goes to depend on our repository, the transitive dependencies end up being 70 megs. And this is like a non-starter for someone deploying on a Cloud Functions environment or any kind of lightweight environment where cold start time and downloading dependencies and all that stuff actually matters. Another reason you might want to do this is if you are in a monorepo environment today, it is not super easy to switch from a monorepo to multiple repos without like lifting and shoving stuff into completely different repositories and changing import paths and all that kind of stuff. So if you want to codify dependencies of individual, distinct packages, then this might be an option too. There's many reasons you shouldn't use this though. So please like think hard and be thoughtful about getting yourself into this situation, because like just the subtleties of what you need to do is tricky, but then also like building tooling for this is hard, and it's, you know, there's not a lot of standardization. So yeah, does that answer the question?
I think so. Just to clarify that transit dependency one, that problem is that you're pulling down all the sources for these to then build the code.
Yeah, totally.
Go away and debuild the code because it's going to prove out the not needed imports.
Right. Well, and even just the downloading of it, right? If you depend on one client out of my 100 that my single repository advertises, then you're signing up to download every transitive dependency of every client, of all the ones you don't use.
I guess the question I have, what happens if you need to have, you want 110 or 100 of the compiler, but you don't want 103? You know what I mean? Do you understand what I'm saying? It's like there's a change in there that's going to break everything else, but I still want the changes you made in this one.
Yep. So the question is, what if you want 100 but not 103? Is that right?
Something like that. Yeah. You don't want it to go to 110 because you guys made a breaking quote unquote change for the code that I had.
Yep. So the question is, what happens if there's breaking changes within a major? If you are making if you are depending on someone making breaking changes within a major, you should depend on someone else, or stop depending on that person, because they're doing Semver like horrifically wrong. And in other languages, I'm taking a really hard stance on this, but in other languages, it's like, oh, this kind of thing happens, and you know, we work around it with exclusion rules or with ranges or whatever. There's some tooling for that in Go. If you know that a specific version is broken, you can use an excludes tag. What the library maintainer should do is go fix that and put out a new version, and then tell everyone to exclude this one broken version, and then things work. However, if the library maintainer is more like, yeah, we're just going to kind of keep that breaking change and, you know, tough love, then what you need is a range. You're like, well, you know, within this major, there's this range of versions that kind of work this one way, and another range that work another way, and that is not supported by Go modules. And it's, you know, like a lot of stuff needs that model to work for this all to be so. I mean, okay, I'm going to say it's simple. Ignore everything we just talked about. If you don't do multi-module repositories, a lot of modules is very simple and kind of easy. And at least you can reason about it. You can understand what's going on. Even in this crazy thing, you can like get it, right? But as soon as you start adding ranges and stuff, like the algorithm becomes so arcane, like no one really gets how a version gets picked and all this other stuff. So, okay. Any other questions before I move on to the next part?
I just wanted to maybe clarify a little bit. I believe there's like something called like an import compatibility rule now. So like that situation shouldn't arise. I mean, it probably will arise in some dependencies, but like the import compatibility rule says that if you are importing a given package by a given path, like that path should never like break you. It has to be compatible.
Yep.
So if a package author does that, then you can just go to them and be like, you're kind of violating the community norm here. You should fix your package.
Yep. Okay. So the next part is more in the line of like maintaining multi-module repositories. Although this one is more, this can actually happen even if you don't have multi-module repository. So what else can go wrong? Well, let's talk about. Let's imagine that this compiler package depends on something in Builder 9000. So when you go to release your compiler package, when you go to release any module, right? What you start by doing is you build it, you test it, and you see if everything works, right? And then if everything's green, then you ship it. It looks good. So let's imagine that I do that, right? I go into Builder 9000. I made some changes to the optimizer and to internal, so I made changes in both kind of places. I go to compiler, I run tests, everything looks good, right? And then I do the tagging, song and dance, and I ship it. But then it breaks users. How did that happen, right? Like how could that possibly have happened? What's happening here is that when you run your tests, it's actually not using your local directory. Unlike in a GoPath world, where if you depend on something that's your ancestor, it is going to use your direct ancestor, like file system ancestor. In a Go module world, the first thing that it tries to do is it tries to find that package in a module, which is stored in the module cache, right? And that lives at GoPath mod. So when you ran tests, you actually ran your tests against the last released version of Builder 9000. So how do you fix this? So the really kind of unfortunate way that you do this right now, it's called replace rules. And it basically says, so let me just go through it quickly. So you go into compiler, you run gomod edit replace, and you're saying, hey, replace github.com jQuery 9000 at this version with this path, like file system path. And then you run tests, and that'll actually force it to run against the ancestor directory, and then you drop the replace rule. And so this forces it to kind of behave like a GoPath world, right? And you need this when you're making changes in multiple modules and you want to ship them as like a single unit. So unfortunate, you absolutely have to make sure that your CI does this. What complicates this in our current transitionary world of, if you're in 11, you might have GoPath on, you might not. If you're in 9, it's definitely off. In a future world where you have 13, it's definitely on, and your library supports like a range of Go versions. That means that your CI system has to handle both cases, right? It has to handle the GoPath case and the module case. So something to be aware of. The good news is that the future, the future gets a little bit better. This is what I was talking about earlier, where I conflated two things. There is a proposal that adds a new command. It packs a directory into a made-up module locally, and then you can test and vet and so on, and then you can clean up your like fake modules. What else do I have to say about that? Okay, and so that's it. So the TLDR is like, be really careful when you get into multi-module repositories. In almost all cases, it's not worth it. If you feel like you do have a legitimate case, then be very cautious and be very thoughtful about it. A lot of your tooling has to change, your CI systems have to change, and kind of your mental map has to expand greatly, because you have to start thinking about users in GoPath and users in modules, right? Just testing it in one place is not going to work. Just for fun, an anecdote is if you choose to do a major version bump with Go modules, you add a v2 tag. If you're in a master directory and you don't do the subdirectory approach, then this works fine and dandy for your users, right? You create a v2 and your master is now a v2, and you create a v1 branch, your master is now a v2. This works fine for modules, but then anyone in GoPath, you just broke them because they always pull in master, whereas a module person would have pulled in v1. Your v1 branch. So it's all this kind of stuff that you have to be thinking about. But on the other hand, your users are a lot happier. They can codify their dependencies and pin and stuff like that. So with that, thank you. My name's John, and are there any questions about anything else? Yes.
With regards to the proxy spec,
yep.
You know how changing the version, I just forgot to phrase this question right. In a multi-module repository, will the zipped download from the cache include the entire repository, or just my carved out specific module that I requested? Yep.
So the question is when there's a module proxy in place, does the zipped cached thing come with the entire repository or just the module, right? It is completely module based. Yep.
In the example you just gave, I'm a little confused. Why did that fail on compiler trying to pull in a version of Builder that didn't exist? Like, did we not update compilers GoMod to require a new minimum version of Builder, or?
Right. So you actually only have to do that require once, right? Right when you carve out compiler, you have to require on Builder at the new version that you give to Builder.
So that's because you're trying to make compiler be compatible with all those versions of Builder.
Yep, and I'm just going to flip way back.
Is that fundamentally different than not testing against all your other external transit dependencies?
Right.
In theory, you have it locked to some version of AWS's SDK. Like, you don't usually test against every single one in the future. You have to trust it.
Yep.
Trust it, right? So can't you kind of just trust that the tests within the non-compiler branch ensure major version compatibility?
Yeah. So this is okay. So let me rephrase the question. So the question is, why didn't we have to retag, and why did how did you say in the beginning, when the compiler?
If there aren't new things in the new version of Builder that I need, such as I open my Go mod, why do I care at all at the compiler level? Like, as far as I'm concerned, it's an external dependency.
Gotcha. Yeah. So the question is, why do I care at all? Like, why shouldn't any version of Builder 9000 work? And why bother at all even testing it on like the later version? Why not just use the cached version? So this is a really good question. An easy example that we found is if you make a change that it's not a breaking change, but it is a change that spans multiple modules. You're adding in new behavior, or you're changing how a feature works or something like that, then you would just want to run all your tests just to make sure everything's still green, right? That all the plumbing works properly and as expected, and so on and so on. Because the alternative is, if you don't do that, then when you push and users go to run your code, if the plumbing doesn't work out, even though like everything compiles fine, the plumbing just doesn't work out such that like an integration test would fail, then you've hosed them and you kind of missed that problem. So it is, in a different way of saying this, is even without making API surface breaking changes, you can break users by incorrectly implementing features or introducing bugs or anything like that. Sure,
but if that breaks that minimum or major version contract, like I'm depending on other external. Yeah. Why is it unique anymore? Like, why is it not? Why is it? As far as I'm concerned, it's just a different. Like, I'm not going to go to test against every single version of S2 because every single version of Google's clients. Why would I care about testing about any other versions of this particular dependency except for one? Yeah, I mean that's fair. You could have that philosophy and like roll with that. I think for us it's it feels weird to make changes and then not that span multiple modules and then not test it full end to end. For the same reason that we run system end to end tests. When we make changes, we just want to feel the assurance that we didn't break anything in unintended ways. But you're right. What you really want is like an n by n, versions against all versions thing, which is unattainable. So why bother at all? Or I guess another way, as a customer of this module, of these modules, MVS will never pick this scenario you're talking about unless I prompt you somehow else. Because my compiler says I need 1.10, and I'm now at 1.3.0. I'm never going to pick a later builder unless something else makes me pick that later builder. Yep. So the comment there was MVS will never pick it anyways unless something prompts it to. So it seems like it wouldn't matter anyways. And you're right. It would be less likely. Yeah, it would be less likely. And you're right. Yep, that's completely right. Any other questions? Any from the stream?
So I had just a question for myself. You mentioned that one of the compatibility features that they introduced was if you don't have a Go mod in your root of your repo, they'll just pretend like there's one there. Mm-hmm. I didn't know that they actually did that. So I guess in the context of a multi-module repo, will it actually, if you have all these Go mods in your repo, will it also assume that there's a parent or a
Yep.
at a higher level as well?
Yeah, so the question is, I had made a comment about how Go modules will consider a repository without a go.mod as a module. Again, no go.mod, it's still considered a module, and that's the only way it could work, right? Because if you think about the day that Go mod came out, no one had a go.mod file, and so it still has to work. So it has to consider every repository as its own module. And so the question is, sort of like if you have these lower level, like below the root modules, how does that work? Is that still carving out? And the answer is yeah, that's still carving out. So I'm going to flip back to like this picture here, right? Imagine that there's no God mod at the root. It's the exact same structure, right? The children are still carved out of the parent. The parent just happens to not have a version, and it becomes even more tedious to make this work without breaking your users, because now when you go to create that dependency, you have to create it against like instead of having a semver dependency, it's like some SHA rev kind of thing. But yeah, it's still carving out. By the way, there's one interesting thing that I kind of glossed over here. Since we have some time, I'll quickly talk about it. But where is it? It's here. So this is an interesting like philosophical thing here. What's happening here is that I am carving out compiler out of Builder 9000, and I'm bumping Builder 9000 to 1.1.0. Is that weird to anyone? Yeah, I actually just chopped off a large part of 1.1.0. That seems like it's kind of a bad thing without a major bump.
What does the tooling do? Like if I'm using Builder 9000 at 1.0.0 and I also use compiler and then I bump Builder 9000 at 1.1.0,
right?
Yes, what happens at that point?
So the question is, what does the tooling do if I use Builder 9000 1.1.0 and then I also use compiler? And that's why we add the dependency, is that it forces you to use 1.1.0. Right?
The other way, right? So like I'm using Builder 9000, I have an import compiler, things are working happily.
Yep.
I go to GoMod and I move it to 1.1.0.
Yep.
That no longer brings down compiler. Does that get in there automatically?
So right, okay, yeah. So the question is, so when I do this carve out and a user is just depending on Builder 9000, but uses compiler, does it bring in the new module automatically and so on? And thankfully, yes. When you go to GoMod tidy, it'll just transparently, and that's kind of the entire basis for this, is that yes, it is a little funky, but it's actually the only way to make this work, is one reason, and two is that the tooling kind of like smooths over the whole thing. You shouldn't even really realize that this is happening. If you bump to 2.0.0, MVS doesn't do this minimum viable selection outside of major bumps. So 2.0.0 is like a non-starter. It wouldn't work. So this is actually the only way to do it. You just kind of have to be okay with carving this out. And it works. It just works. So it's like pragmatic. Okay. Final call for any questions. Anything else on the line?
I just had one question to wrap things up. So it seems like there's like a lot of consideration that you have to have for both like GoPath users and GoModule users, and there's a lot of existing code out there that's not compatible with modules, and it seems like there's a lot that has to be done to get the community, get this entire ecosystem onto modules.
Yep.
Like, I don't know if you have any insight into the thought process as far as the transition is going to go, but like, how long do you think it's going to take for us to get to the place where everyone's on modules?
The question is, it seems like it's pretty hard, and like, how long is it gonna take? Is it gonna just be a rough road for everyone? Like why are modules so hard to use, et cetera, like that kind of thing, right? I'm gonna speak as an opinionated, like, personal individual and not as a Go engineer for a minute. So take these as my thoughts, not like Russ's thoughts, because he's a genius and I'm not. This is why I start the talk with I am talking about multi-module repositories, and almost no one should use them, but they're interesting, so that's why we're doing this talk. And also that 1.11 is like this beta state, this alpha state. So there's a couple of things. One is that people are running into a lot of problems with modules because it's just not fully baked yet. And that's because we want this to be a community exercise where we all build this thing together, as opposed to Google builds this like polished thing and tells everyone to use it, right? So it's very community driven, and it's a process. So in fact, you probably shouldn't be using modules period today if you're not ready for some like a little bit of rough stuff, right? In 1.12, you maybe you should start using it or thinking about using it. And in 1.13, you definitely are going to be using it. But like today, if you're using it, you are essentially like an alpha tester in some ways. That's the one thing that's tricky, right? It's hard to be on both sides of like, I want to use a polished thing, but also I want the community to be very involved in the language, right? About multi-module repositories and just how many steps and how much it takes to think about it. Once GoPath goes away, a lot of stuff gets a lot simpler. So that's the good news. The transition period and this backwards compatibility thing makes it so much harder, but this is the price that we pay for not having a Go 2.0, right? And I think that's a good thing. And then the second thing is that that a lot of this is intended to be smoothed over with tooling, right? So I showed you these manual steps of having to like force MVS to bump you up and to like add these replace rules in your go.mod and all this other stuff. But in the future, there should hopefully be like a Go release tool that just does it for you, and you type in some inputs and whatever else, or something, you know, or checks and all this other stuff. So tooling will hopefully make it a lot better. And then the third thing is that I can tell you with certainty that there is a massive amount of documentation being worked on to make this just clearer and more understandable, the parts that need to be. I'm actually the person that is writing the documentation for this, and it'll be out next week. So does that answer your question? Hopefully alleviate some concerns?
Yeah.
Okay. TLDR, it'll get better, we hope. Okay, well, thank you everyone for coming. I really appreciate your time.
So we got plenty of food like normal, so if anyone wants to grab some on the way out, you're welcome to it.
Please take the food.
Yeah.